This is a video presentation of Chapter 1, Section 7 in the 7th grade book entitled Translating Words into Math. So we spent some time working with some algebraic expressions. Now we're going to create some algebraic expressions given some word phrases that represent them. A lot of the time when we work with word phrases, what we'll end up doing is actually just kind of translating them in order, and that will generate an algebraic expression. We just have to make sure that something like that makes sense. For instance, if I said to you, I'll give you a very basic one that doesn't even throw a variable at you, subtract 3 and 2. Well, it wouldn't make any sense to write minus sign 3, 2, because that's not a subtraction problem. Of course, the subtraction problem would be 3 minus 2, and that would make sense. But as long as we apply a little bit of common sense, usually translating these pretty much in order will get the job done. Now, what's essential, though, is you know what all of the different keywords mean. And that's what you see on the right side of this first slide of notes in red there, the different keywords for the different operations. Obviously, some things are going to translate verbatim. For instance, if you see the number 6 in a word phrase, that's going to translate as 6. So we don't really have to think too much about that. But we do have to make sure that we know what all the operations translate as. So as you can see, when we mean addition, you might see the words add, or plus, or sum, or more than, or increased by. Subtraction will make its presence felt by using the words subtract, minus, difference, less than, decreased, take away, or less. Multiplication will make itself known using times, or multiplied, or product, or the word of. And division will put in an appearance when we see divided, or quotient, or per. And obviously there's some other words that you will see, but I think they're more obvious. For instance, if I say twice something, right, you know that means multiplication, and I'm multiplying by 2. So obviously we can't list every single case, but again, those should be somewhat obvious for us. Now, the other one that you're going to run into that's not actually an operation, but something that's going to translate, is you're going to see a number, or what number, or the number, or something like that. That's your variable. And unless they tell you what variable to use, you can pick any variable you want. Now, I'm here to tell you that most textbooks don't feature a lot of variety when they come to that, and they use mathematicians' favorite variable x there. So you'll probably see a number, what number, the number, translating as x a lot. So let's go ahead and start this on this first slide here, where they're asking us to translate the quotient of a number and 4. So the first thing they're pointing out there is the word quotient. Quotient means division, so we're writing a division question. Now, if we were to translate this in order, we'd be in trouble, because it would be division sign, and then the next part of the statement says a number. So again, that's your variable, so you're going to write x there. And then it finishes with 4, so 4 is just going to translate as 4. But obviously, division sign x4 isn't a problem, because the division sign has to go between the two things that we're actually dividing. So not quite in order, but pretty close. This is actually going to change into x divided by 4. Okay, here's w increased by 5. So increased by, as you can see, they go back to the list that you saw in red on the previous slide, and they point out that that means addition. So this is an addition problem, and there's only 2 things in the statement, so it's pretty easy. They've got w, and they've got 5. So we've got to be adding together w and 5, w plus 5. Now realize that by the commutative property that we've already studied, we can write this the other way. Doesn't hurt anything. We'd still get the same answer. So if I wrote 5 plus w here, you'd still get a correct answer. All right, think about it in terms of numbers. 3 plus 2. If I flipped it around, 2 plus 3. Well, the answer is exactly the same. So either way I write this, unless I use the wrong sign for increased by, right, I should be able to get this one right. Now, C is a little more complicated because now they're going to start throwing multiple operations at us. They've got the difference of 3 times a number and 7. So difference is one of those keywords that we need to make sure we know what that means. Difference means to subtract. So we're going to subtract two things is what they're telling us. And what are we subtracting? Well, we're subtracting 3 times a number and 7. So 3 times a number is one of the elements in the subtraction problem, and 7 is the other element in the subtraction problem. Now, obviously, we have the word times in there, and there's your other operation that we referenced. That is, of course, going to be multiplication. All right, so we're subtracting 3 times a number. Well, remember, the number part, that's your variable. So we're multiplying together 3 and a variable, 3 times x. Right? And again, we said in the beginning, we're subtracting. What are we subtracting from that amount? We're subtracting 7. So you see it says 3 times x minus 7, which they've simplified just by a little bit by writing in 3 times x as just 3x, which is the same thing. It's an equivalent statement there, 3x minus 7. Okay, let's look at the D question here. It says the quotient of 4 and a number increased by 10. So what's probably easiest for most of you looking at this is to treat this in 2 parts. All right, we'll start with the first part there, which says the quotient of 4 and a number. Well, quotient, if we look back at that list in red on the first slide, means division. So they want us to write a division problem that involves 4 and the number, which is, again, our variable. So you can see they've written x divided by 4 there in the beginning of our answer. And that will represent everything before that bracket I made there. Now, after the bracket, it then says increased by 10. Well, increased by, if we look back at that list in red, means addition. So now I want to write an addition sign, and since I'm increasing it by 10, after the addition sign is going to go 10. And indeed, that's what I've written there, x divided by 4 plus 10. So the quotient of 4 and a number increased by 10 is x divided by 4 plus 10. Now, question number 2 is going to ask us to use these concepts here in the terms of a story problem. One of the things that you're going to need here is a formula that you probably use in science a lot, the distance formula. Distance traveled, is equivalent to rate multiplied by time. Rate, some of you are probably a little bit confused by that maybe. Think of rate as speed, like miles per hour in a car. But of course it doesn't necessarily have to be miles per hour. It can be any distance time comparison. Feet per second, or miles per year, or if we're talking about a runner, maybe meters per hour, whatever. It's a distance and time comparison there for rate. So we're going to use that formula here to work through these examples. Again, distance is equal to rate times the time. So this is a great point at which, if you're looking at this in science, you'll be looking at this stuff in both science and math and looking at those connections. So, now, that said, let's go ahead and take a look at question 2, which said, Mr. Campbell drives at 55 miles per hour. Now, that, of course, is a rate. All right, notice it's written as a rate. It says miles per hour. Rates are comparisons of 2 units. Rate here is the speed, distance, and time. All right, miles per hour, so that's your rate. We're supposed to write an expression for how far he can drive in h hours. So they're telling us that the time here is supposed to be called h. Well, remember, distance is equal to the rate times the time. If the rate is 55 and the time is h, I multiply those together for the distance. So it's 55 times h. Done. Okay, the B question does not use that formula, but it will have us do the same translation type work. It says on a history test, Maritza scored 50 points on the essay. Besides the essay, each short answer question was worth 2 points. Write an expression for her total points if she answered Q short answer questions correctly. Okay, so let's look at what they're saying here. They're saying that the total points include 2 points for each short answer question. And those short answer questions are called Q. Now, let's think about it. Let's say she got 1 right. What would we do in terms of a mathematical problem there? We would do 2 times 1. If she got 7 right, we would do 2 times 7. If she got 10 right, we would do 2 times 10. If we don't know how many questions and we're just calling it Q, which is what the question describes, we're still going to do the same thing that we were doing in all those other problems. So we're going to do 2 times Q. So that's the first part of the answer, 2 times Q. Now then they're telling us that she's also going to get, in addition to that, key phrase there, in addition to that, 50 points on the essay. So we're going to add 50 to the 2 times Q. And indeed, that's the final answer here. 2 times Q plus 50 scores together the 2 points for each short answer question and the 50 points on the essay. 2 times Q plus 50. We'll continue on here. And we'll continue on with the concluding examples in the check it out section here. We're supposed to, in number 1, write the phrase as an algebraic expression. 4 times the difference of y and 8. So let's break this one into pieces. Now, forget that this says 4 times the difference of y and 8. If this just said 4 times, let's make it something simple, 7, you would write 4 times 7. So we already know that we're going to take 4 and multiply it by something. We're going to take 4 and multiply it by this entire thing here, which says the difference of y and 8. Well, that's kind of its own little problem. Difference, if we look back in that red list of keywords from the first slide, means subtraction. So it's a subtraction problem that involves y and 8. Well, that's pretty easy. Y minus 8. But remember, we're going to take 4 and multiply it by y minus 8. Now, notice the way I wrote y minus 8 there, y minus 8 is in parentheses because 4 has to be multiplied by this entire thing. If I didn't write it in parentheses and I wrote it like this instead, realize that the order of operations is going to take precedence then and make me do 4 times y first. But it's not 4 times y. It's 4 times this entire thing, which is why it has to be in parentheses to make me work this part out first. In number 2, it says Julianne works on an assembly line building computers. She can assemble 8 units in an hour. Write an expression for the number of units she can produce in 8 hours. So let's just say Julianne worked for 1 hour. What mathematical problem would be solved to figure out how many computers she made? Well, we would do 8 times 1, because she makes 8 computers an hour, and she worked for just 1 hour. If she worked for 5 hours, what problem would we solve? Well, we would do 8 times 5, because 8 times 5 is 40. Let's say she worked for 10 hours. Then we would do 8 times 10, because 8 times 10 is 80. But we don't have that here. We don't have a time. The time shows up here as a variable h. But we're still going to do the same thing. So it's not going to be 8 times a number, it's just going to be 8 times our variable. 8 times, in this case, h. Final solution.